Japan has been hiding a secret new $1 billion weapon deep in the mountains, and it just revealed a stealth fighter jet that has China and the US terrified. This ultra-modern upgrade of the F-22 Black Widow is shockingly fast and lethal, and it's about to change aerial warfare in Asia forever. Can it outshine its competitors in the world of fighter jets? And why was it rejected by the United States military in the first place? Join us as we delve into the modernized F-23 that Japan has resurrected. In today's rapidly changing global geopolitical landscape, we're witnessing the emergence of formidable stealth fighters from countries like Russia and China. Amidst this transformation, a next-generation fighter jet that was initially turned down by United States military officials in 1990 has resurfaced and is poised to enter the fray with its impressive capabilities. Questions abound regarding this multi-role stealth fighter, which has now found its way to Japan. Can it outshine its competitors in the world of fighter jets? And why was it rejected by the United States military in the first place? Join us as we delve into the modernized F-23 that Japan has resurrected. But before we continue, we would like you guys to subscribe to the channel, like this video, and hit the notification bell icon so you do not miss out on any amazing and entertaining content. In the late 1970s, American spy satellites detected new and powerful Soviet fighter jets, the Su-27 and MiG-29. This raised concerns in the United States because these Soviet planes were expected to outperform existing American fighter jets. Instead, they were seen to have advantages over the American models. In response, the United States Air Force, USAF, sought information from aerospace companies in 1981 to explore potential features for an advanced tactical fighter to replace the existing F-15 Eagle. This aircraft, designed by McDonnell Douglas, had been a twin-engine, all-weather tactical fighter jet. In 1981, the USAF requested ideas from aerospace companies to create a better fighter plane than the F-15 Eagle, focusing on air-to-air combat. The new jets, called the Advanced Tactical Fighter, aimed to utilize advanced technologies such as lightweight materials, improved flight controls, more powerful engines, and stealth technology. Different companies were asked to submit proposals, and in 1985, the USAF officially sought designs from various manufacturers. Concurrently, the U.S. Navy planned to replace its F-14 Tomcat with a version of the Advanced Tactical Fighter through the Navalized Advanced Tactical Fighter program. In 1986, several companies submitted proposals for a demonstration and validation phase. Lockheed, Boeing, General Dynamics, McDonnell Douglas, Northrop Grumman, and Rockwell participated in the competition. Lockheed and Northrop were selected as finalists in October 1986. Subsequently, the Lockheed YF-22 and Northrop YF-23 were developed and tested as prototypes over 50 months. The YF-23, designed to meet USAF requirements for survival, supersonic cruising, stealth, and easy maintenance, underwent testing. It was designed to fly at supersonic speeds without using afterburners for extended periods, similar to the B-2 Spirit and FA-18 Hornet. The YF-23 prototypes, named Grey Ghost and Spider, underwent testing in the early 1990s. These planes were designed to be less detectable by radar and infrared systems, featuring unique design elements. Although the YF-23 briefly sported a red hourglass shape similar to a Black Widow Spider, this was later removed. Initially, there was consideration of using a version of the YF-23, called the NATF-23, for Navy planes to replace the F-14 Tomcat. However, it was found that the regular YF-23 design wouldn't work well on aircraft carriers due to challenges with space, handling, storage, landing, and takeoff. In 2001, Boeing donated a wind tunnel model of the YF-23 to a Veterans Memorial Park. The YF-23A, also known as DP-117K, had distinctive features such as diamond-shaped wings, a V-shaped tail, and a high cockpit for improved visibility. Its tricycle landing gear, with one wheel in the front and two in the back, facilitated landing and takeoff. Additionally, its weapons bay was located under the plane between the front and rear landing gears. With two turbofan engines on either side of the plane, the YF-23A featured trapezoidal front openings with special panels to absorb turbulent air and vent it over the wings. The YF-23 had two versions, one with Pratt & Whitney engines and the other with General Electric engines. Unlike the YF-22, the YF-23 didn't use thrust vectoring. Instead, the exhaust from the engines went through troughs lined with tiles, similar to those on the B-2 bomber, to cool and shield them from heat-seeking missiles. The YF-23 was capable of flying fast without using afterburners, with its flight controls managed by a computer system. It could roll by raising flaps and ailerons on one side while lowering them on the other. The V-tail fins could move for pitch control, and the tail fins could rotate for yaw control. Test pilot Paul Metz remarked that the YF-23 could handle high angles better than older planes, up to 60 degrees. To slow down, the wing flaps and ailerons on both sides could act like brakes. During testing, some parts from other planes were used to save money. The planned F-23 design, equipped with either the F-119 or F-120 engines, would have differed from the YF-23 prototypes in several ways. Instead of one weapons bay, the new design would have had two bays in the longer front part of the plane. The front bay would carry short-range A-9 missiles, and a rotary cannon would be on the left side of the front part. The overall length of the plane would be slightly longer with a bigger interior space. The nose would be larger to accommodate mission systems like radar, and the front part would have less noticeable changes, raised to the same level as the front edge of the wing. To keep the plane's shape smooth, the thrust reversers were removed, making the engine part smaller and rounder. The inlet design changed from a trapezoidal shape to a half-circle bump. The pattern on the back of the plane and tail would have fewer serrations, and the engine thrust lines would be angled in by 1.5 degrees from the center. The naval NATF-23 version, shown in drawings in the 2010s, differed significantly. The diamond-shaped wings were moved back as much as possible, and the plane had regular vertical tails instead of the V-tail with serrations for better stealth and maneuverability at low speeds on aircraft carriers. It could fold its wings for storage on the flight deck, had stronger landing gear, a tail hook, canards for carrier landings, and thrust vectoring nozzles. The intakes were shaped like a quarter circle with serrations and a bumped surface. The NATF-23 had a wider wingspan of 48 feet and a shorter length of 62 feet. The first YF-23, powered by Pratt & Whitney engines, reached a speed of Mach 1.43 on September 18, 1990, while the second, with General Electric engines, reached Mach 1.72 on November 29, 1990. Comparatively, the YF-22 reached Mach 1.58 in supercruise. The YF-23 was tested up to a top speed of Mach 1.8 with afterburners and could tilt up to 25 degrees, although its actual top speed remains a secret. Sources suggest it's more than Mach 2 at high altitude. After the competition, both YF-23s were sent to NASA's Dryden Flight Research Center at Edwards AFB, California, without their engines. NASA planned to use one of them to study how well predicted loads matched actual flight results. But this plan didn't materialize. The YF-23s remained in storage until mid-1996, when they were sent to museums. After being rejected, the YF-23 disappeared from the spotlight, only to resurface in Japan. Thousands of miles away from its birthplace, this fighter jet rose again in a modernized form within the framework of Japan's ambitious F-3 stealth fighter program. Spearheading this effort is Mitsubishi Heavy Industries, a powerhouse in Japanese aerospace innovation. The collaboration with U.S. aerospace giants Lockheed Martin and Northrop Grumman marks a significant shift in Japan's defense strategy, indicating an intention to leverage cutting-edge U.S. aerospace technology. The resurrection of the YF-23 isn't just a revival of an iconic aircraft, but a strategic move to position Japan as a formidable player in global defense. The collaboration aims to capitalize on the strengths of both nations, Japan's expertise in electronics and jet engines, and the U.S.'s proven track record in stealth technology. This synergy is strategically aimed at addressing the limitations of existing platforms, particularly the F-35. Success in the F-3 program could establish Japan as a key player in the export of advanced fighter aircraft, fostering strategic partnerships with other nations. This could contribute to a more interconnected and collaborative global defense landscape, where shared interests and challenges drive joint initiatives in technology development and capability enhancement. One of the F-23's standout capabilities is its impressive speed, having demonstrated a cruising velocity of Mach 1.8 without afterburners. This underscores its high-performance attributes and positions it as a formidable force in scenarios requiring rapid response and agility. Beyond its speed and aerodynamics, the F-23 stands out due to its integrated circuit design, which offers advantages over traditional models by reducing frontal resistance. This design enables increased internal volume, a critical feature for stealth aircraft carrying armaments internally without compromising radar visibility. This feature enhances the aircraft's ability to engage air and ground targets while remaining virtually invisible within the enemy's weapon range. Furthermore, the F-23's technological prowess is demonstrated by its capacity to achieve effective control at supercritical angles of attack, reaching up to 60 degrees. In the realm of fighter aircraft, maneuverability is a paramount factor, and this capability positions the F-23 as a potential game-changer. The revived F-23 as part of the F-3 initiative embodies a strategic balance between maneuverability and stealth. This technological equilibrium is particularly noteworthy as it positions Japan to carve a unique niche in the global defense landscape. Collaborating with U.S. partners, Japan aims to leverage the F-23's technological advantages, aligning them with its expertise in electronics and jet engines through initiatives like the ATX program. Despite the promising outlook of the F-3 program, it faces challenges and considerations. Bringing back the F-23 raises questions about its acceptance in the U.S., where the F-22 and F-35 are already in use. In 1990, the U.S. chose the F-22 over the F-23, so introducing a similar aircraft now entails recognizing past decisions and potential issues. For the F-3 program to succeed, it requires approval from different authorities, such as the Pentagon, the Senate, and the White House. These decisions are complex and involve politics, strategy, and money. Additionally, the reception of the F-3 by the U.S. military and its compatibility with existing capabilities will be closely examined. In addition to the F-3, Japan plans to introduce the FX, also known as the Godzilla FX, a twin-engine stealth fighter characterized by its considerable size. This size aims to extend the fighter's range and augment its payload capacity. Notably, the technological innovations trialed in the X-2 technology demonstrator are slated for seamless integration into the FX fighter. Defense Minister Taro Kono has emphasized the FX's robust network capabilities and remarkable ability to carry a more extensive arsenal of missiles than the F-35. The complex process of creating the FX begins with detailed initial designs, carefully inspected using a 3D digital system. These blueprints are adjusted to match the FX's expected performance. Subsequently, a thorough evaluation occurs using a high-tech simulator created by the Technical Research Division. Skilled pilots from the Japan Air Self-Defense Force use this simulator to closely examine a large set of data including avionics, stealth features, and engine details. The evaluation includes simulations of air-to-air combat to provide a comprehensive assessment of the design's effectiveness and identify areas for improvement. The new FX represents a significant upgrade compared to its predecessor. One major improvement is the replacement of old hydraulic systems with new electric actuators, making the plane's interior more efficient. This switch to electric actuators is necessary for stealth operations, as the plane has hidden weapon bays and air ducts. Electric actuators are easier to install and maintain compared to hydraulic systems, simplifying the installation process, reducing weight, and enhancing maneuverability. The fighter jet utilizes modern techniques to create a light and flexible structure, combining materials with adhesive molding and reducing traditional fastener needs. Advanced methods such as computer-aided design and finite element method models help thoroughly check the plane's structure, reducing weight and streamlining production. To manage heat from avionic systems, a special heat transfer system is carefully integrated. This system effectively manages heat production, ensuring optimal performance. The FX also features special sensors to detect stealth aircraft, including advanced radar and radio frequency sensors. Additionally, the fighter has a strong RF self-defense system to counter potential threats from other aircraft and missiles. The helmet-mounted display system provides the pilot with a wide view and multiple features like voice recognition and 3D sound, enhancing situational awareness and mission effectiveness. To minimize radar detection, the FX incorporates twisted air ducts, keeps its weapons internal, and utilizes advanced technologies like electromagnetic wave absorbers. The XF-9 engines provide significant power output, crucial for running the fighter's advanced technology and equipment. These engines feature special nozzles that can move in 3 dimensions, enhancing maneuverability and stealthiness. The development of the F-3 and the FX is viewed as an opportunity to strengthen Japan's defense and aerospace industries while establishing a robust presence in the international arms market. The capabilities of Japan's resurgent YF-23 stealth fighter will reshape power dynamics across the Pacific. Make sure to subscribe and click the bell icon so you don't miss our next in-depth analysis on military technology.